Hi, everybody. It's Professor Mitchell. We have come to just about the end. This is chapter 13 on conic sections, and we're actually only going to be covering two sections in this chapter. So the first section is 13.1, which is on the parabola and the circle. So let's start by talking a little bit about conic sections. Conic sections are named, so each conic section is the intersection of a right circular cone and a plane. So one of the conic sections that we'll be talking about in this section is the circle. And that's what you get when you intersect a plane with a cone, well, like you see in the picture, so that the plane is parallel to the floor. If you tilt the plane a little bit, you get what's called an ellipse, which is a type of oval. We'll be talking about those in the next section. And then if you tilt the plane a little bit more so that it is parallel to the top part of the cone, you get a parabola. And you'll remember we talked about those in chapter 11. And then finally, if you make the plane almost vertical, you get what's called a hyperbola. And we're going to be talking about those in the next section. All right, so we'll start with the parabola. Just as y equals a times x minus h squared plus k is the equation of a parabola that opens upward or downward, like we talked about in chapter 11, x equals a times y minus k squared plus h is the equation of a parabola that opens to the right or to the left. So first, let's review some of the parabolas that we talked about in chapter 11. Y equals a times x minus h squared plus k. If a is greater than 0, remember the parabola opens up. And remember also that the vertex is at the point HK. And in this case, the axis of symmetry is the vertical line x equals h. If a is less than 0, the parabola opens down, all right? But your vertex is still at HK. Your axis of symmetry is still the vertical line x equals h. All right, so now if you flip it around, and notice what's happened is that we've interchanged the x and the y, and we've also interchanged the h and the k. Your vertex is still at the point hk, but now your parabola opens to the right if a is greater than 0, and opens to the left if a is less than 0. Notice the axis of symmetry in both of these cases is the horizontal line y equals k. All right, so in this first example, we'll graph the parabola x equals 4y squared. So if you match that equation up with the one we were just looking at, a is 4, which means the parabola is going to open to the right. And h and k are both 0, which means the vertex will be at the origin. All right, and the axis of symmetry is the horizontal line y equals 0, which is the x-axis. All right, so if you make a table of values, and what they've done in this case, I think this is a little odd that they did it this way personally. I'm going to do it a little differently in the next example. They've chosen some values for x. And what makes this even weirder is, so for example, when you replace x with 4, you get 4 equals 4y squared, which gives you y squared equals 1 when you divide both sides by 4. Notice that that equation y squared equals 1 has 2 solutions, right? So that gives you 2 different points. And then if you replace x with 2, you get something even weirder. I think that's, again, a very strange choice for x. 2 equals 4y squared. And now if you divide both sides by 4, you get 2/4 equals y squared, which means y squared equals 1/2. Y would be the positive or negative square root of 1/2, which according to the calculator would be plus or minus 0.71. Okay. So there's those points plotted on your rectangular coordinate system. And when you connect them up with your parabola, you get that rightwards opening parabola there. All right, next example. We're going to graph the parabola x equals y minus 4 squared plus 1. The vertex is 1, 4. Remember that with the sideways parabolas, the k is what's in with the y, and the h is over here. The axis of symmetry is going to be the horizontal line y equals 4. And again, it opens to the right because a is 1, the invisible 1 right here. Okay, so now I'm going to do this a little bit differently. I think this is a little more logical. When your equation is solved for x like this, I think the most logical thing to do is to choose values for y. And it doesn't matter which values. Notice that we already know about the 0.14. So if you remember the advice I gave you in chapter 11, I would start with y equals 4 and maybe pick a couple of values that are bigger than 4 and a couple of values that are less than 4. All right, so for example, 3 and 5, that's one that's less and one that's greater, and then 0 and 8, one that's less, one that's greater. That should give us a really good picture of what this parabola looks like. So what you might want to do at this point is pause the video and see if you can come up with those x values, and then come back when you're ready and we'll compare notes. All right, so hopefully you've tried that. And again, we already know when y is 4, x is 1. When y is 3, let's see if we can figure this out. 3 minus 4 is -1. The square of -1 is 1, and 1 plus 1 is 2. All right, when y is 5, 5 minus 4 is 1. 1 squared is 1. 1 plus 1 is 2. Next, we have 0 minus 4 is -4. The square of -4 is 16. 16 plus 1 is 17. And then finally, y equals 8. 8 minus 4 is 4. 4 squared is 16. 16 plus 1 is 17. So we plot those points. I had to do a little bit of repair on this graph because it didn't really look that good when I first did it. I should have a point there for the vertex. I didn't think about that. But anyway, well, here, you know what? I'll just do it right now. Okay, vertex would be right about there. Okay. All right, so then your parabola is going to look something like that. And your axis of symmetry, again, is the horizontal line y equals 4. All right. Now, this is something that I didn't talk about in chapter 11 because there aren't any homework problems about it, actually. So I just decided we would do it a different way. And the way that I'm going to explain it right now, you don't have to do it this way. All right. We're going to graph the parabola y equals x squared plus 12x plus 25. So we could have done this problem in chapter 11, right? So the way that I did not show you how to do this in chapter 11, but which you may find helpful for doing your sideways parabolas, is completing the square. All right, so we're going to complete the square on this equation so that it comes out in the form y equals a times x minus h squared plus k. So the first step is we're going to subtract 25 on both sides. Then we're going to do our magic trick. All right, does this feel like it was a long time ago? We're going to take that 12 right there. We're going to divide it by 2, which gives you 6. And then we're going to square the 6, which gives you 36. All right, so then we're going to add 36 to both sides. Notice now that the right-hand side is a perfect square trinomial. So when we rewrite that, we get the square of x plus 6. On the left-hand side, we combine the like terms, which gives you y plus 11. And now if we subtract 11 from both sides, we get y equals x plus 6 squared minus 11. So what is the vertex of this parabola? It would be -6 comma -11, right? All right, a is greater than 0. Again, we have that invisible 1 over here. And the axis of symmetry would be the vertical line, x equals -6. So your graph would look something like that. All right, and that brings us to circles. A circle is the set of all points in a plane that are the same distance from a fixed point called the center. And that distance, that fixed distance, is called the radius. All right, so here is the standard form of the equation of a circle. X minus h squared plus y minus k squared equals r squared. And by the way, that comes from the distance formula. The center of that circle is hk, and the radius is r. Okay, so for the first example, we have x squared plus y squared equals 9. Notice that you can write that equation in the form x minus 0 squared plus y minus 0 squared equals 3 squared. We're trying to identify h, k, and r. All right, so the center of this circle is 0, 0. And the radius of the circle is 3. And the graph of the circle would look something like that. Note that, of course, that line segment is not part of the graph. They're just showing you that fixed distance of 3. When you do this in your online homework, by the way, there's going to be something called a circle tool. And when you click on the circle tool button, the first question it's going to ask you is, where is the center of the circle? You have to plot the center. And then just plot any other point on, plot any point on the circle. So in this case, I could go 3 units up, I could go 3 units down, 3 units any direction, okay? And it will automatically draw the circle. But my recommendation with every single graphing problem is to draw it on paper first and then do it on the computer. All right, next example, graph x minus 3 squared plus y squared equals 9. So the trick to all of these problems is to identify h, k, and r. So if we write this equation in standard form, it looks like x minus 3 squared plus y minus 0 squared equals 3 squared, which means that the center of the circle is 3, 0. And again, the radius is 3, just like in the last example. And your circle ends up looking something like this. All right, so again, if I was doing this in the online homework, I would click the circle tool. It would ask me for the center, so I would click on 3, 0. And then it would ask me for any point on the circle. I could go over here. I could go to the origin. I could go directly up here. It doesn't matter. 3 units in any direction. Okay, this one's a little different. They want us to graph x squared plus y squared plus 4x minus 8y equals 16. So I'm happy that we just had that little bit of completing the square practice a few minutes ago, because that's exactly what we need to do to get this in the right form. Okay, so the first thing we'll do is group the terms together, put x's with x's, put y's with y's, and then you have to complete the square on the x and also on the y. So here it might be helpful for me to bring up a text box. So first I would take that 4 off the x. I would divide that by 2, which gives me 2. And then I would square that 2, and that would give me 4. So the first thing I'm going to do is add 4 to both sides. But then I also have to complete the square on y. So I'm going to take that -8, and I'm going to divide that by 2, which gives me -4. And then I'm going to square the -4. Notice that means put the -4 in parentheses, right? So that would give me 16. So not only am I going to add 4 to both sides, and do make sure you do it on both sides. Probably the number one most common mistake I see students make is they only add it to the left side. All right, you're going to add 4 to both sides, but then you're also going to, let me bring up another color here. You're also going to add 16 to both sides. Hopefully this writing won't sit over top of what comes up on the computer next. Okay, so let's see what we have now. All right, we've added 4 to both sides, and we've also added 16 to both sides. They reversed their colors from what I did. Let me get rid of this stuff over here. Actually, I'm getting rid of everything. Okay, so now we have a couple of perfect square trinomials. This is the square of x plus 2. This is the square of y minus 4. And of course, 16 plus 4 plus 16 is 36. So again, remember we're trying to identify h, k, and r. And be careful with your signs. Remember the formula is x minus h squared plus y minus k squared. The minus is built in. So in this case, h would be -2, k would be 4, and r would be 6, right? Because r squared is 36. Okay, so now that we know the center is -2, 4, and the radius is 6, it's very easy to draw the graph. It would look something like that. All right, this problem is sort of the reverse of what we were just doing. Now they're telling me the center and the radius, and they want me to write the equation. So this is actually easier than what we were just doing. So we're going to take our standard form for the equation of a circle, which is right there. And we're just going to plug in h, k, and r. All right, so h is -7, k is 6, and r is 2. Notice the double negative there. Be very, very careful with those signs. So after you clean that up, you get x plus 7 squared plus y minus 6 squared equals 4. And that's the equation for that circle. And that's going to do it for section 13.1. We'll see you next time for the very last section we're going to cover, 13.2. See you then.